All right, class, we're gonna try another example here real quick. We have another function, and the question is to determine whether the function is continuous. Determine which of the following rules for this continuity is first violated at a equals 2. So we can see it, a equals 2 is here, right? But we're gonna determine which of these these rules are violated. So let's look at first one, f of a. So this is the same as f of 2, right? Because a equals 2. And we can see here in the graph that f of 2 is actually defined to be -3, right? Right? There is actual point at a equals 2, right? So there is an actual value and -3. So what would be non-defined? Well, it would be if this actually happened to be an open circle just like this, or maybe this one didn't existed, then this would have been the case where there was no dot, no period for f of 2. All right, so this one seems like it's doing fine, but that's not disqualifying. This is not being this does not violate the continuity of a function. Now let's try the next one. So let's look at whether the limit of the function as x approaches a exists, right? And this translate if we're looking at a equals 2, this actually translates to be the limit as x approaches 2, right, of f of x, right? Does it exist? And so we look at this as x approaches 2, right? The value of the function is increasing, right? Increasing, right? If you notice, the function is increasing, and it's actually approaching the y value of 1. And if you notice, also from the right side, so actually we just noted the limit as x approaches 2 from the left side is equal to +1, and it's actually the same as the limit of f of x as x approaches 2 from the right side. Right, let's make that argument. As x gets closer to 2, we can see the value of the function is also getting to 1. You notice, as you get closer and closer to, as x gets closer to 2, the y value of this gets closer to 1. So they're the same. So therefore, this one does exist, right? And it's equal to 1. So it seems like these two actually are doing just fine. These are satisfied. So so far we haven't violated any rule of discontinuity. So let's look at the last one. The last one, if we translate this will be the limit of f of x as x approaches 2. Does this equal f of 2? Right? That's what it's asking us to determine. And if we notice, it actually is not, right? This actually fails. This fails. So let me write a note here. This fails, right? So this is the one that is actually violating the rule, because we can see here, obviously, that -3 is not equal to 1. So this one right here is equal to 1, and this one right here is equal to -3, right? So those are two different values. So therefore, this is not satisfied, right? So it fails to be true. It fails to be true. So therefore, to determine the answer for the next part, it says, is the discontinuity at x equals 2 a removable discontinuity, a jump discontinuity, or a limit discontinuity? Well, this is going to be a removable discontinuity, because we can actually change this position. If we have the power to remove just one point, we would move this point so that it fits right there, right? So then that means that by moving one single point, then we have removed the discontinuation. So this is a removable discontinuity. There you go. All right. So I hope you guys find this helpful. Please let me know if you have any questions.